dun. Alright. We don't really have that many cards this chapter, though. The nice thing is, aren't they just rules? I think they're just rules this chapter. So we have to know our rules, or else we're in big old trouble. So one more time as the forevers are eventually loading. And for anybody who is joining us just now, you had to miss school today. Long story short, finishing 4-7 today, peeking at the worksheet that I'm not giving out until after school if you want to come in, or tomorrow. We'll have a full day on the worksheet tomorrow. There is going to be a test review. It's already on your homework page. It's due with the homework spiral of course, but we'll be going over questions and reviewing on Wednesday specifically on that review. And on maybe a few particular problems I'll put on the board that might be tricky or helpful to look at. And then our test is on Thursday. So our forever quiz will be on, why is it not there? I need to reload it probably, huh? Cards 40, is it 42 to 44? 43 to 44. I'm double checking real fast. But, yep, we already did. So just 43, 44, and 45. Good thing we moved it till Wednesday. You guys are going to see this one today. But you already know kind of these formulas. They're just a rearrangement, but it's not bad. So we'll do 43 through 45, and it's probably good for having it on Wednesday. All right, kids, here we go. Let's get going, huh? Before we look at this example, I mean, you guys already have been looking at it, but let's really quickly go back and say inverse trig. Why is it tricky? Tricky trig. What? Tricky trig. It's a lot of use, and there's trig here. I mean, it's inverse trig, but there's trig here, but what's not over here? You're not even warned. I mean, you have squares, and it's in the denominator, so if you learn these rules really well, maybe you'll start to pick up on it faster. But these look a lot like normal use sub problems, and use sub problems where you might be choosing, well, probably not that, but that maybe, or that, and it's not gonna work. Even integration on crack can't crack this. What? Maybe there's a different version of crack. Anyway, so, cracking a code? Maybe I should reword that next year. Anyway, so, more hidden. Why isn't this a normal? Can you guys tell? Don't write it. If I was mean, I'd say write it, and I'd say, here, let's go, and then, oh, it doesn't work. Why should you not choose the U I'm choosing? I know it's a Monday, but why doesn't it work? Yeah, do you see how we don't have what we want? Now, does that mean it's totally awful? No. But when we go to plug in, one of the t's is going to go away with one of these t's, right? So we could say, hey, let's solve for t squared. Ew. Right? Let's not do that. Now, I don't mean that that's never the answer, but in this one, it's not. Solving for t squared. We rarely want to do integration on crack going back and solving for something where we have to square root. That is rarely the answer. So, which inverse trig does this seem to fit? Arctangent. The only one without a square root, right? The only one without a square root says, let's get 1 over, is it a squared plus u squared or u squared plus a squared? A squared plus u squared. But does it really matter? No. No, because addition is commutative. So we could do it this way. We have 1 over a arctan of, or I'll do tangent inverse because of space. They're the same thing, right? Arctan, tan inverse. That's our rule. So, let's go choosing stuff. Like, who's A? Got it. Who's U? Do you see it? T squared is squared? T squared is squared? What's du?
Oh, isn't it A?
Yeah, it's easy. du is 2t dt. Some of you might have skipped this step and tried to go straight to the answer, and you would have it wrong because we need a 1/2. We need a 1/2 to make it work. So we're going to do the integral of du. Can I pull out the 1 over 2 out here, guys? Is that okay? But I still technically have an over t. I have a t up here, and I have u squared plus a squared. What happens to my t's? They're out of there. understood 1 chilling up there. Now can I jump to my integral rule? Yes. So 1/2 times, it's time for the rule. 1 over a, 1 over 4. Arctangent of who? Or tangent inverse of who or what? U over a. Let's see. Now some of you are getting a little bit stuck on this step. How would we write the final answer? 1/8 tangent inverse of t squared over 4 plus, we could name this little guy 2c1 and make this 2 times c1, or we could just say, hey, whatever, you're a new c, which is why I never show this step, and which is why I just show a new plus c. Technically, it's a different c than the 1 and the 4 if you do put the brackets. You could shortcut this process just a little bit, and you could just do something like this and then say plus c. Every now and then, though, that's illegal to separate. But in this one, you multiply the c by 1/2. Whatever, it's a new plus c. No big dealio. Dun 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 dun. Some more hidden, but maybe not impossible. So try this more hidden, but maybe not impossible one. Compared to the inverse trig. Some of you might want to start multiplying out, but no, please don't. You're not going to be happy if you try to multiply out. This fits an inverse triggy one. This fits an inverse triggy one. What is that old comment? Oh, Ziggy. Never mind. So much more fun if it was tricky. What do you guys think? Who's A? Yep. Who's you? Who's DU? I'll give you a couple more seconds. As I do. We'll do our attendance real fast. So Sam, we had you sleeping in, okay? That was just out.
Yeah, he was really good.
Yeah, it's not for attendance, I'm just giving them the sense of motivation. See if his phone on it? Probably, right?
Yeah.
Do you want to text him? Just be like, hey man, I'm doing okay. And then otherwise everyone's here, right? Might be barely here, but we're here. Alright, cool kids. Let's see if you got it. Final answer, after plugging in, you get really quickly to 1 over a squared plus u squared, which is arctangent. Yet again, there is no crazy extra stuff for us to worry about, so we can go straight to 1 over 1 arctan. Let me write it this way just to show they're both the same. Of u over a, which is just x minus 2 plus c. Dun, 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 dun. Any questions on it? The struggle is when you go to the test review and they're all mixed up and you don't know which ones are supposed to be inverse trig and which ones aren't. But you have examples you can go back and compare to from section 4.5 and 4.7 and 4.6. That might help. That's why I want to get you guys to that test review as soon as possible because all the examples are mixed up. Let's get to a much more interesting one. Well, this doesn't quite look like the ones above. Does it? I can't make x my u because I have a 6x right next to it. Maybe it's a u sub and there's a way we can make it work? Just a hint. U sub like this, it's gonna fail miserably, I promise you. I could make a point, but I've already made enough points this chapter, I think. So we'll just say it doesn't work. Angela, you had a good idea. What'd you say, kid? Yep. Oh, no. Yeah. Why? Because we have to. There's no other way. And how does it help? If you guys don't believe me, you'll see in just a second. Why am I putting plus somebody and minus somebody? What do I have to make sure if I start putting stuff in that I do? I have to keep it balanced, right? And I don't have both sides, so I'm not going to add to both sides. On one side, in one expression, I have to add something and subtract the same thing to keep it balanced, or else I'm in trouble. Does anybody remember how you complete the square? What's special? Divide by 2, which is going to be -3. That looks like a 2, which it doesn't. And then square it. Take the middle term, -6, cut it in half, and then square it. What do we get? So then plus 9 minus 9 cancels out. Yeah? Why on earth did we do that? Remember how up here I told you guys not to multiply out? It was written the way you wanted it? We're trying to get it to look kind of like that. So then coming back down here, we need to factor. And when we factor, we end up with -1 x minus 3 squared plus 4. Josh, would you mind popping the door open? Let's just there. So completing the square, something that showed up in Algebra 1, maybe the bane of some of your existences. Oh no, is it gone? Oh, stink. Check behind the trash can. See if that's any better. The nursery was in here on Sunday. Maybe out in the hall? Alright, you just stick the trash can in the door and we'll just... Someone stole my doorstop. Okay. Why did we do all the complete and square craziness? Because now, who's our A? Not 2. Who's our U? We just need to get it to arctangent form. You see it? It was really bad back here. Now it's doing a whole lot better. So we can go ahead and make it -1 over u squared plus a squared du. At which point we can make it straight to our formula, except the negative, I guess you could pull the negative out if you really want to. You would end up with -1 over a arctan, which is the same thing as tangent inverse of u over a plus c. Now, technically, some of you might remember the inverse trig formulas. Whenever there is a negative, you could go to the other one, like arc cotangent. But to be honest, I have not seen the AP guys in an integral ever go backwards to arc cotangent, arc cosine, or arc cosecant. Instead, they usually just make it negative of arc tangent, which, to be honest, is the same thing. Which is kind of weird if you think about it. So I don't know, take it or leave it. I just want to make that quick little, technically we could go to arc cotangent because of that negative. However, that's not what I have seen the AP do. They usually stick to arc sine, arc tangent, or arc secant. So I'll write the arc cotangent one just so we know, but that's not for you guys to necessarily stress about. Okay. What else do we got? Ooh. That's really review though, but hey, the test is coming, that's alright. That's really review, but hey, the test is coming, that's alright. This may or may not have to do with inverse trig, aka it doesn't. However, your homeworks at this point have included all sorts of stuff, everything from finding the area, to solving a differential equation, to finding an equation of a tangent line. You're like, what? That's from last semester. Yep. The review's starting to get all mixed in, little by little. So this is review from section like 4 or 5. maybe even like last part of chapter 4a. How do we solve for y if we're given dy dx? We need to go backwards. The only way to go backwards is to get things looking right. And to get things looking right, we move him to the other side, right? Gotta remember that first step or else we're in big trouble. Now what do we do? Yeah, throw in an integral. The integral of 1 dy is just on this side. Ew, gross. Don't integrate him. In chapter 4a, some of you're struggling with the whole write the radical in an exponential form. 1/3, good. Careful. Whatever the power is of x is the normal power, like up here. X to the 1, we still make it x to the 1, but with the radical we think of, hey, over, or think of the line in the radical, if that helps. And then the 3. Now we got this. It's a Monday, but this is review. How do we integrate x to the 1/3? Yeah, and if you guys need to see it, remember we can make it plus 3/3, right? What's that fraction? 4/3. We multiply by the reciprocal. Plus c. Make it a lot prettier. Y equals 3/4 x to the 4/3 plus c. We're done. No, we're not. Why not? We need to go find our c, right? But is 2c? No. Remember? F of, that's our x value, that's our y value. We gotta plug it in, define c. So at which point we can now go ahead and bring down the 2. Equals 3/4 times. And how well does your brain process 4/3 kiddos? When it's 1. When it's 0 or 1, we're good. When it's anything else, like, oh, it is 1. Never mind. But just in case it was something other than 1, just to help you out just a little bit, remember this is the exact same thing as 2 equals 3/4 times, not with a parenthesis, times the cubed root of 1 to the 4th. Just to make sure if it was something like 8, hopefully it wouldn't be 8. 16, that would be nice. To be able to solve it a little bit better. But 1 to any power is still. So you can go ahead and cross all of that out. We just have a 1 left. 3/4 times 1 is 3/4. 2 into 4ths is 8/4, right? So we can subtract the 3/4 to the other side. That gets us our c. So c is equal to. And it's very, very important that you realize what they're asking for and who do they actually want. The entire function with its plus c. So we end up with y equals 3/4, x to the 4/3 plus 5/4. Okay. We are done with section 4.7. We're grading that homework tomorrow, and I don't think it's super long.
No, it's not.
Okay, it's not super long. However, as I said, we're starting the integration as net change. However, it looks weird. It looks different. Yes, we're making our own little baby section out of it, but not a big one. We're going to put this thingy here. Where did I see it? Hold on. We're going to put this thingy here. And we're going to make this chapter 4 and 4.I, like imaginary?
Yeah. It's imaginary. So 4i.
Alright, we'll have fun with it. We'll have fun with it. There you go, 4.I. Don't get confused by it. Long story short, it's the end of chapter 4. And I don't have a section for it. Bridget, what's up, kid? Yes, I'll be here until at least 4. At least 4. Yes, I'm going to plead with Algebra 1 kids to come in and get help after school for their test tomorrow on exponents graphing exponential functions by just making a little table with like -1, 0, 1 and putting it in. And geometric and arithmetic sequences. But like the basics, like find the pattern, identify common ratio, common difference. So if you guys are looking for tutoring hours, and if Algebra 1 sounds a whole lot easier than calculus or pre-calculus, maybe you can drop by today and be available. Hopefully they come. If you show up willing and ready, I will give you a half hour, even if no one needs your help. I'm literally bribing and begging and pleading for those Algebra 1 kids to come. I have no idea if they will. Lunch, I can beg and plead. I'll give you a half hour if you're here to tutor Algebra 1 kids at lunch. Alright, you guys getting these formulas down?
Motion. You mean the top box or your
The top part's not a forever card, but the top part tells us where this comes from. The top part, the top part, the top part tells us where this comes from. Do you guys have integration as net change as the title, so I can get rid of it? That's rough. Speaking of which, Richmond. Yeah, he's not feeling good. Oh, God. Maybe I'll double check this. I did, but maybe didn't. You guys remember, this is an old forever card, right?
Yeah.
You guys are pleased to do that one with us?
Yes.
Who won?
Super Team 6 or something.
Let's go team. You actually got to pick it? Oh, you could win. It was because of her goal she scored. She was on. Okay, these formulas, if we were to solve them out, net change in position, which is the exact same thing as displacement. It's the final minus the initial. Net change in position, which is the same thing as displacement, which is the final minus the initial. In motion, we can say technically the final amount minus the initial amount. And in motion, we're talking about distance, so it'd be like S of B minus S of A. This is just basic FTC. To find the integral of V of t dt, we're going to go back to the antiderivative of velocity, which is position, which could be S or x. Plug in the top bound minus plug in the bottom bound. That's FTC. What do you guys notice that's different in your forever card down here? Am I talking about a change in, or am I talking about one specific position? So how do we solve for one specific position? Well, we take the formula that we do know, and what do we do to it? We solve for S of B by adding what to the other side? Oh, wait, that's just like algebra, right? You say the final amount minus the initial amount when you're given the integral of the rate of change of the amount. You just add the initial to the other side and say, whatever, I can solve for him too. So what's different in this forever card isn't the formula, it's the arrangement of the formula. So then coming down, we talk about the forever card because he's the guy that we need to really, really focus on. Let me finish my highlighting of the box. This is forever number, do you guys remember, was it 45? Cool, thanks. And you only need forevers 43 to 45. Two formula cards. Actually, 3 formula cards. And one of them, ln, you guys should already know. Integral of 1 over u is ln of u plus u. But integration is net change. What is going on? In words. The final amount, or the final, let's say the final number, the final count, is equal to, I don't want number. I'm going to change it back to amount, sorry. In terms of applications, that'll be much more helpful. Final amount is equal to the initial amount plus the definite integral of the rate. Now I didn't put the whole definite integral from a to b, but the final amount is the amount at b equals the amount at a plus the definite integral, which represents how much the amount changes between a to b. Remember, if we integrate rate, we're taking the change in the amounts, s of d minus s of a, or f of b minus f of a for FTC. It might look a little bit different because in this case, we're talking about an initial amount, calling him f. Remember, f is just whoever is the main person in the problem. Sometimes he's in the integrand, sometimes he's out. But we know that whoever's in here is going to be the derivative, and whoever out here is going to be the antiderivative. I'm going to go ahead and get rid of all that nasty highlighting. Okay, you guys almost have the card? Good news is, since you guys don't have your worksheet, you don't have to write any of the problems down. You're going to be getting them tomorrow. However, you might want to write down some of the hints that we're going to give, and even some of the answers we're going to get in the next few minutes, because whatever answers you get are the exact same answers you can write down, or the work we give is the exact same work you can write down in finishing that worksheet for Wednesday. Remember, all day tomorrow in class, we are working on integration as net change after we grade the 4-7 quiz on Wednesday. You guys got it? Let's go see what's the first problem. And as you guys are looking at the first problem and reading the question, you don't have to write the question, but if I were you, I would write multiple choice, number 1. It says worksheet 8-1, it was someone else's chapter 8, it's our chapter 4. That's how different our book is. But it has all the important stuff. I'm going to start passing out your tests. However, as soon as I get the test passed out, I'm going to come back and give us at least the answer to this one and maybe the next. The first few, I'll tell you when it stops. It's going to stop at Corey. The first ones are my A's. Ryan Murphy, Angela, Katrina, Eileen, and Corey. This time these are the only A's, but some of you, many of you, did higher than you have been doing on my test, which are good. A few of you scored lower, though, which is why corrections will be worth 1/3 points back. Haley, can you go close the door for me? Here's the rest in no particular order. Andrea, Charlie, Brendan, Maya, Violet, Alan, Sam. Yep, I'm booking it.
Right here.
Charlie. Brendan. Ethan. Jason. Lauren. Brandon.
So bad.
Sarah. Trent. Caroline. Aaron. Haley. Yeah.
We have to essay for AP Lit.
Bridget.
Mine was on is handling a better case for suicide or setting. And I printed out 2 topics.
Ella, Josh, Laura, Christian,
The first one says living or suicide, and the other one says to drink the bleach and to not drink the bleach. I don't know which one should I turn it. It's good. It's like a talk about it.
Ella. All right, grab a seat.
I knew this one. I was like,
All right, guys, eyes at the front. Let's see if we can get this answered. Maybe one more. The graph at right shows the rates at which the water is pumped from the storage tank. Approximate the total gallons of water pumped from the tank in 24 hours. Are they asking for a change in what happened between that time, or how much is in there currently? Are you sure?
no, how much less?
They're asking what happened between 0 and 24. Well, hold on. If I have a rate, how do I go back to gallons? If I have a rate in gallons per hour, how do I go back to just gallons? I need to integrate, but I can't. So I need to approximate the area, and every single square is 6 by 50. Every single square has an area of 300, right? So how many squares do I seem to have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe these two would be like 10. And then this one is almost 11-ish, with maybe some of this guy down here, and then like 11.5-ish maybe, almost 12. We'll pretend 12. I think I almost did 12, and I got that one, and I got that one, and that gets this one. What's 12 times 300?
3,600.
Done. What? Yep, that could be an AP question. What about this one? The rate at which customers arrive at a counter to be served. What are they asking for? To the nearest whole number, how many customers arrive over the 60-minute period? All you gotta do is say, hey, however many customers arrive, all you gotta do is take the integral of f of t dt, but what can I plug into my calculator?
Okay.
There's no work to show, there's just a calculator thing to plug into. Kiddos, come with your calculators tomorrow. We're gonna work on this worksheet and try to figure out the difference between integrating and integrating plus initial amounts. I'll see you guys later.